Good afternoon, guys. Can you hear my voice?
Yes,
Yes,
sir.
sir. Good afternoon.
Okay. Good afternoon. We will start the class. We'll wait just 1 or 2 minutes. We'll start the class. Let me share my slide. Could you see my screen?
Yes,
Yes,
sir.
sir.
Visual.
Just let me see. Okay, so we got 53 students. All right, so let us now start today's class. Many of you would have heard what is operating system. Like many of you would have used in your respective laptops or in your smartphones, heard like Android operating system or Windows 10 operating system, Linux operating system, and so on and so forth. Uh, but what actually an operating system does, and what actually the behind the screen, what happens, is what we're going to thoroughly look into this course. May not in depth, but at least you'll get an idea what are the jobs of operating system by this end of this class. But in detail, the things that we are going to study, we will go through briefly what actually a brief overview of operating system today. But as we are discussing, if you're not able to understand or if you feel bored or if you want to ask questions or interact, feel free to do that. But a brief overview you will understand. In the subsequent classes, we will try to discuss few concepts in detail. Okay. In the lecture 1, I gave you a brief overview of what actually is a computer, what are the input devices, what are the output devices, what is the storage devices, what is the difference among them, and with try to picture, I try to show them. We try to understand by various pictures. I guess most of you would have uh, most of you would have understood that class, and if you are not, please go through the lecture 1 slide. But one has to be very clear what are the input devices, what are the output devices, what are the storage devices, and what actually is operating system does with this all these devices. We have to be understanding, right? When I say IO devices, it's actually input output devices. Okay, so is this clear? Like whatever we discussing so far, is this clear, right?
Yes, sir.
Okay, one more thing is I would like to teach my class strictly in Hindi, strictly in English, not in Hindi. If you are not able to understand also, if you are facing any difficulty in understanding the language, please you can stop me. I will repeat and try to make you understand. That can also we can try to do, but because our college students are representing from across the country at different places, I believe English everybody will understand. Okay, so with that assumption, again let us start today's class. So today's class will be more theoretical. There won't be much pictures, but then these are very important things also. There are no other way to put you to, if there would have been a class, I could have made more interactive way of discussing things by asking questions or by interacting. But since this is online class, due to some limitations, there are many things I have to explain in the slides using text rather than image. So please bear with me. So an operating system is a software. First, you have to understand that operating system is a software. It's not a hardware that manages computer's hardware. So we have computer hardware, we have printer, you have CPU, we have processor, we have memory. They're all hardwares, right? You have monitor, they're all hardwares. Now, when I open and see, as I showed like in the previous class, the operating system what I'm using now is Windows 10. Now what happens in Windows 10 is like there is a hardware where each and every instructions are executed, but I want to run an application, say in browser. Okay, so for example, now I'll show you that there are, you can see my screen, right? There is a browser. This is a browser I'm taking the class, the browser I am using to log in into MS Teams, and I'm using PowerPoint presentation. So these are all application software that we try to understand. But how this how when I want to, when I'm clicking it to full screen, or when I'm pressing an escape and trying to move to the other screen like browser, how it happens is like uh, inside the monitor displays what I'm trying to say using my input action, using keyboard or mouse. I'm trying to do something with my mouse, giving some instructions. So when I do something on my mouse or keyboard, those instructions will be fetched to uh, the particular process which is executing inside the processor, right? So each process will be stored in a RAM, and the RAM will take the instructions to execute that. And once we do that approximately, I mean like appropriately, we could able to see that corresponding actions are happening. The hardware is responding to the actions what I'm doing. Who's managing the hardware? Like the screen should be projected, or the mouse, when I do something, the respective action should happen is the hardware manager is who does that is software called operating system. Okay, so an operating system acts an intermediary between the computer user and the computer hardware. So in earlier days when a computer was introduced, the first computer operating system looks like DDoS operating system. Okay, just it looks like command prompt. If you go to command prompt, let me show. You see, this is the command prompt. When you turn on your operating system, this will look like this: Microsoft Windows, Microsoft Corporation, all it looks like this. Now when I want to access a file, I want to see what are the file, I have to give commands like these are my list of files. And if I want to change to a particular directory, say C2 change directory to desktop, everything I have to give in command lines. So again, I want to see some files. You can see that when the date was created, the time, what is the file name, everything. It looks like this was the original operating system when it was developed, when it was designed, okay, in earlier days. The purpose why an operating system is needed is to have an interface with hardware. Now dealing with hardware understands only ones and zeros. It's very difficult for a human being to communicate with the hardware. So operating system will come and as an interface. This is called command line interface. Okay, everything what I want to do, move or command, you would have learned in first year programming about Linux, like various command lines. Even the Windows was like that. The Linux operating system, I will show you that. By the end of the class, I will show some demonstration also, how you can carry out. But an operating system, when you turn on a machine, it will look like this. But now the operating system, when you turn on, it is looking like this. You have a graphical user interface. You can change your screen. You can you have a browser that will make you to connect the internet. How you can see that interface? See, when I'm clicking the interface, like I can easily go to just by mouse clicking to a particular drive. You can do this all. This is called graphical user interface. Okay, this is graphical user interface. As the technology evolved, the way we are interfacing with the hardware evolved. Okay, the graphical user interface is also nothing but an act of communicating with the hardware. Right now, this is my hard disk. What I'm doing when I'm clicking F drive, when I'm clicking C drive, when I'm clicking F drive, what I'm trying to do is I'm trying to access my hard drive, which is having the storage of my files. So when I click this drive, I'm directly accessing the my hard drive, inside the hard drive with a mouse click. So my input mouse click is making some action. I'm instructing an operating system to open a particular file in a hard drive. So this graphical user interface will help me to do that. So when I click a particular file or a folder, the operating system understands that what I want, and it will communicate to the hard drive. The operating system will communicate to the hard drive, and via processor, right? Everything happens via processor. The operating system does that via processor, and it fetches the file. It loads the file from hard drive to RAM to processor, and there you go. You will open the file. Okay, this file has been opened. So when a user wants to communicate anything, it happens the same with your Android operating system also. When you touch something on your screen, when an app should open on the top of it, the app is not an operating system, right? You install Microsoft Teams or you install YouTube, you install Gmail. They are not operating system. They are a particular applications. But however, an interface will be there between you and the hardware of your smartphone, which is nothing but an Android operating system, will act as an intermediary that will manage your hardware resources for you. Okay, so that's what an operating system does. The fundamental responsibility of an operating system is to allocate the resources to the programs. So now you have to understand two things. One is we have resources and we have programs. Okay, the resources means we have a processor, we have memory, we have input output devices, we have storage. These are all the resources. Now I want to run an application, I want to run a program. Say I want to project this PowerPoint. So that is one program, and I want to when I want to run this program of PowerPoint, inside what happens is when I try to open this PowerPoint, a process will create inside the operating system. The process will be assigned with an unique ID, and the process, if it has to work, it needs to be executed by the processor. So what operating system will do is it will load that particular application to main memory, and set by set of instruction it will try to read what is input, what is output, all the devices it will try to execute instructions by loading into memory to processor. Does this make sense what I'm saying so far?
Yes, sir.
Yes,
Yes,
sir.
sir. Fine.
Yes, sir.
Yes.
Okay. So in other words, we can say that you see this, we have a computer hardware, we have a processor, memory, input output device, and on the other end we have a user. Like I'm user, you are looking at other user. What operating system does is the operating system will act as intermediary between the computer hardware and the application programs. The application programs is nothing but the web browser which I am using or the PowerPoint. These are the application programs which make my job easy as a user. The operating system will communicate predominantly with application programs and computer hardware, and it can you can consider this application programs and operating system as a one block. Then the operating system is indirectly making a favor of user communicating between the user and the computer hardware. Okay, but user, the operating system will start. But if you want to run particular application, you want to play a video, you want to start a PowerPoint, you want to access an internet using browser, then particular application you will install. This applications will interface between you and the operating system. Does this make sense?
Yes, sir.
Right. So as I told, the user views are different because nowadays you have laptops, PCs, mobile devices such as smartphones, tablets, embedded computers. There are so many devices. So user view will change. Like some user view will do with touch screen. Some user view like how an operating system should work. Like nowadays, voice recognition, like Siri will come. I will say something and it will recognize and it will start an application. Or with a little user view, like how the gamma, there is no user view at all. Like if you come with embedded operating systems, like washing machine or refrigerator, we use real-time operating system. There also we have operating system is working behind, right? You air condition, you control with your remote, your TV screen, you control with remote. There also we have some operating system is going on. We call that as a real-time operating system. Perhaps you will study in your upcoming courses, okay, in electronics. So predominantly we will use microcontroller, power electronics will come. For that you will use microcontroller, which is nothing but a embedded C programming. It's looking like more or less embedded C programming. So that will, if any program has to work, you need to provide some interface to make it work, right? So there you will use real-time operating system. So user view will change, but the operating system, the purpose is designed is to make users ease of use. Now instead of going to a command, changing directory from one folder to another folder to a file, I would feel very easy by touching a screen to open it, or by just moving a mouse click, which is very predominantly easy than typing entire command. I have to remember the commands, what are the commands that I need to execute. If the command is wrong, or if the instructions what I'm trying to give is wrong, that will make my job difficult. Instead of that, I'll just click on Z and click and play. That is very easy, right? So the operating system is designed mostly to make ease of use and some attention paid to the performance and security, and let excuse me, less attention paid to the resource utilization, means how this hardware and software resources are shared. Now when I run 2-3 applications, for example, now I'm running PowerPoint. Now I want to play a video. Now what will happen, this monitor, I want to do both at a time, playing a video and showing a PowerPoint. Will it be possible?
Yes, sir.
Right, but now sharing my whole screen. Now either now I want to play some, I want to see what is the Google News today. Suppose I will click here and I will open a Google News. Now I want to show the what is the presentation. Now I can do one at a time, right? Means the monitor is shared to a particular process. I mean, like it is sorry. The monitor is now the PowerPoint is using my monitor, right? When I want to play some video or watch some video, then the monitor will be used by the other application, right? Now, but this both application I am simultaneously running. I am running this PowerPoint screen sharing using Microsoft PowerPoint. Then in my memory, both this process are shared. If either one of them will not work, you will be not able to see the slide. If my PowerPoint stops working or either browser is stopped working, either this case, you will be not able to see what is happening in the screen. So my PowerPoint and the browser, they both are running simultaneously inside my processor. They are shared. They are sharing its memory. They are sharing the process execution. So these both are softwares and sharing the hardware resources. So it would be difficult for me to handle all these things as a user to make understand the hardware, but operating system does that. So these are the purpose of how operating system is designed, how and hardware and software resources are shared, how to make it very ease of use. And when we design an operating system, of course we need to pay some attention to the performance. Like when I design an operating system, my system should not running very slowly or very fastly. That it should not happen, right? So we have to make sure that performance and security also matters. So there are many things we need to look after that when we consider an operating system. Is it okay? Shall we go ahead?
Excuse me, sir.
Yes.
Sir, I got that this points, 4 points which you explained, but I did not understand that what is user view, sir.
User view is like how an user will try to look into few things. Okay. Like for example, the user, how he is interacting with the hardware, how a user is interacting with the hardware is what user view is. Okay, in the sense user, how he is interacting with the hardware. Some interact with hardware using voice, Siri app. Some interact with touch screen. Some interact with keyboard and mouse, like how we do with our personal system. Some with no interaction, like when you do with like I said, real-time operating systems like air condition or some other ways, you will not interface at all with an operating system. The view
Sir, what are the
yeah, the view of operating system, how it should be, it changes, it varies from application to application. That's what I'm trying to say.
sir? There is written little or no user view, sir. What does that means? Like,
That's what I'm saying. It's like when you are using an application like microwave oven, how do you use an operating system there?
sir, we set the buttons and it starts functioning like that.
Because it's very limited. It's very little view.
Yes, sir. Yes, sir. Okay, sir. I got it.
And because you touch screen in your smartphone, you predominantly do the user interface should be very touch, right? Most of the things you touch and play. You can do that using voice recognition, like Alexa, Siri. Most of the things also you will do with voice recognition. There also the operating system is working, but there might be some applications where you will be interacting with very less, one or very less view, and there will be no user view also, and there will be very less little view. That's what that it varies. There are many views of how you are looking into an operating system. So operating system is not, one should not restrict yourself that no, it should be only touch screen, no, it should be only voice recognition, no, it should be only keyboard or mouse. It's not like that. Operating system can be viewed as different views with different aspects. It varies from user to user and application to application. That's what I'm trying to say here.
Yes, sir. Fine, sir. I got it.
Right. So operating system is most intimately involved with hardware. Okay, so one way we can see that operating system is a resource allocator. How the processor and the memory, input output devices, they are all allocated with respect to a particular application or a particular process. Program is what we can view as an operating system. This is system view. Okay, user views from how an application will launch, but a system view will look operating system as resource allocator. Okay, from computer perspective, if you see what is an operating system is, it is a resource allocator. This is system view, right? So a computer system has many resources that may be required to solve a problem, like how much CPU time I should give to a particular process. So if I allocate say 1 hour to a process, if another process I want to execute, second process, should I need to wait till that process will finish? If the first process will finish, then or can I make it some other way to efficiently using my CPU? How my memory space is shared, how my storage space is shared, is many things we need to look into it. And that's how from the system point of view, a computer system has many resources that may be required to solve the problem. If two processes competing, that I want the memory space or I want the storage space or I want the printer, whom you will decide that who will go first. Okay, so there are many things involved in this. From system point of view, an operating system is a resource allocator, but from user point of view, it might be a simple way of communicating with the hardware with ease of use. It might be via touchscreen, it might be via uh, voice recognition, it might be via keyboard, whatever it is. So the operating system acts as a manager of all these resources. So the operating system must decide how to allocate them to specific programs and users so that it can operate computer system efficiently and fairly. Right? So that's what the operating system does. Now suppose, for example, I want to run an application, and that process is executing now. So in between, in order to complete that process, in between, it needs an input output device. Now what process will do, it will say that you go and do the job of input output device. Until then the process will sit idle, right? Because if it executes one process at a time, if the processor executes one process at a time, and if the process leaves in between to do some other input output device activity, the process will sit idle. Whereas that time you can fetch the second process and leave in between and come back once the first process input output job is done. Then process 2 can wait for some time, but it can execute to some extent. So that's where we will try to execute processes, how the process management will happen, how the CPU utilization will increase, how the speed of processor is too fast, but the RAM speed might be very slow, how this mismatch can be executed. Suppose if your RAM is 2 GB and you want to play a movie of 4 GB, will your system will be able to play?
Yes, sir.
No, sir.
How is how is it possible? It will not play.
Sir, but initially, like when 512 MB RAMs were coming, then also like movies were playing of 1 GB in parts, sir, like that it is distributing. Sir, when a small mobile used to come, that time also we were watching movies there. So
In
then
your,
how was that possible?
yeah, yes, exactly. So how your in your smartphones, if you are using, if you play a movie which is more than your RAM, your mobile will play now.
Yes, sir. Yes, sir.
So how does it does that? I mean, your data file, what you are accessing is more than your RAM, but still the system is able to play. how the memory is managed there is also an interesting idea. All these things will be handled by operating system. Okay, there is a called virtual memory. I will discuss that in the upcoming slides, but in detail we'll discuss in the subsequent classes. But you will be able to play because of virtual memory management. So the memory management, the process management, and the storage management, file management, how a file is stored where. When you install an application, say you install one application, that application will be stored in C drive in a particular order, right? You install Windows operating system, you install program. So when I install Microsoft Office, so it creates a Microsoft Office folder. Inside the Office folder, it creates some document, set of documents. I did not created this, right? I did not created this, but when we install an operating system, by default it created all this set of files, how it should work. That goes with every application. So how the files are managed, because the way it stores, when I'm trying to run an application, it works properly. When I'm projecting Microsoft PowerPoint, it goes to that particular position where it installed. The processor fetches from that particular place and loads into the main memory and executes by the processor. So how the files are stored in a way that the applications are running properly, how the operating system manages all these things is what actually it's decided. Like the operating system must decide how to allocate the resources what we discussed, like CPU time and memory space, storage space, input devices, and the users can operate the computer system efficiently and fairly. Okay, so this is what an operating system does. So a slightly different way of the operating system we can emphasize emphasize as the need to control the various input output devices and programs. So the operating system, the another a slight different view is you can control how an input output devices and the user programs are controlled is also one view of an operating system, which is the main role of operating system. Operating system control is also called as a control program. So a control program manages the execution of user programs to prevent errors and improper use of the computer. So it is especially concerned with the operation and the control of input devices. This is another view from the system view perspective. Does this make sense? What we are trying to discuss?
Yes, sir.
Right. So let us define now an operating system. In the previous class, I gave some definition, but that is just for your understanding. But this class, we will try to understand in detail what is the definition of operating system. See, the fundamental goal of a computer system is to execute programs and to make solving the user problems easier. Right. That's what the computer is doing now. Now I want to. We are conducting this online class is because an operating system is coming and helping us to a great extent, and the programs have been executed. On the other side, we are able to listen to the class. We are able to run this multiple programs at a time, which is solving our problem and making it very easy, right, to take the class. So a computer, not only with respect to this application or with respect to any other application, if you want to watch a movie, to capture a movie or to convert that into a good editable image and providing that an interface, it's very difficult, right? Now in olden days, if you want to watch a movie, we used to go to theaters, right? We used to go to theaters, but now the interface has been so developed, like you can watch in many apps like Netflix, Amazon Prime. You're just sitting and watching that. Those are all a different technological perspective, but that has nothing to do with operating system. But however, when the operating system is when you're trying to play in your system on your mobile, it's executing the programs, and even though they are complicated, it is making our job easy. Okay, indirectly the operating system is coming into the picture where it's making the ease for our to achieve our goals. So computer hardware is constructed to make it very fast. Now I want to calculate two large prime numbers for the security purpose. and hardware could be an easy way. That's why the calculators were invented. The calculators are helpful to some extent, but if you have to run an application like a simulation, like how a rocket will launch, it will go in orbit in a particular position. These are all things we could do it in hardware, but if you go for sophisticated applications, there is need of uh, general purpose hardware. That's where the main goal of computer invention is to have a general purpose scientific calculator, right? It's not just a calculator, but in if I want to run any application with respect to general purpose, that is a main goal for the invention of computer, but which led to dramatically or drastically bigger way of achieving things. But a computer goal is achieved to execute programs and making solving the user problems easier, but bare hardware alone is not particularly easy to use. So application programs are developed. These programs require certain common operations such as controlling the input output devices, and the common functions of controlling and allocating resources are then brought together in one piece of a software called an operating system. Okay, does this make sense what we are trying to say? So the fundamental goal of a computer systems is to execute programs and making solve user problems easier. To do that, we went for computer hardware, but computer hardware is alone is not helpful to make these applications, to make programs or solving our problems easier, and hence application programs are developed, particular applications are developed, but these programs need input output devices to control them, and a common function of controlling and allocating resources are then brought together into one piece of software called the operating system. Does this make sense?
Yes, sir.
Okay, so there is one more couple of things you need to understand is the operating system is a one program running at all times on the computer, usually called kernel. Okay, the operating system is one program running all the times on the computer, usually called kernel. So what happens when you start a computer? So when you start a computer, how the computer hardware will remind that this is the operating system it should load. Anyone has any idea?
Sir, in BIOS it will select hard disk and then it will load from master boot record the location and kernel image will be loaded.
Okay. Anyone else? How many of you heard the word bootstrap? Bootstrap program. Anyone heard bootstrap? B-O-O-T bootstrap STARAP strap program.
Yes, sir. I heard. I used.
Sir,
Right.
in what
So
way, sir?
yeah, so when you turn on a computer or a laptop, what happens is the first program that will load is Bootstrap program. The Bootstrap program is a permanent program which will provide you the link to the operating system. So when you turn on a computer, the power will come and see the first program is Bootstrap. From there, the operating system is linked and the processor, the operating system is loaded first into the main memory. Thereafter, it is keep on executed by the processor, and that happens by the time when you start the operating system. Okay, when you switch on and when you see some colors are coming, what happens inside that is Bootstrap program is loaded. It is loading your operating system and it is executing your operating system, and once the operating system is executed, it will stay in the computer itself, which is the main program of operating system, is called kernel. Even though you don't run any application, you don't run Microsoft PowerPoint, you don't run browser, you don't run anything, you turn on your computer, just sit idle, by default, the operating system will keep running on the background, because operating system is also a software. Operating system is also software. When I say software, a software is again a set of programs. A program is again a set of instructions. A set of instructions are executed by the processor, right? So by default, some space of RAM will be occupied in the main memory by operating system always, to make it the use for the user, and it will act as an interface. That main one program is called as a kernel program. And the kernel, there are two types of along with the kernel, there are other two types of programs will load. So one is system program. System programs, like as I said, which is not necessarily an operating system, but with are associated with an operating system of the kernel. I will explain that what are those system programs are in the upcoming classes. Like for example, when you are running a compiler that happens, I mean, like it has a linker, loader associated with the many things, which is not an operating system, but still you need them to make it your application work, right? Likewise, if the application programs are which include all programs not associated with the operating system, like the application programs is like what we are trying to do now, like Microsoft Teams. Microsoft Teams is in a program. VLC Media Player is an application program. Browser, your Chrome is an application program. Microsoft Office is an application program. You are trying to run that on the top of operating system to make it work, which is nothing to do with your operation of the operating system. They are application programs. But beside that, there are some system programs like Firewall. Firewall is also part of operating system, but it will help you or defend to some extent, right? For example, this is give me 1 second. Now I'm connected to this LAN, right? When I want to connect this to this LAN, if you see this some application, let me show this. Ethernet. You see here Intel or Ethernet connection. Something is there, right? Which is a device driver. Inside a device driver is running with Intel Ethernet. If I can see the properties, you will get some information, which are system programs. Okay, that is not an operating system, but in order to make my internet connection good enough, it will help me to provide an interface of software, right? So this is some network adapters, some applications, they are all system programs. You can say that they are system programs, but they are not operating system, but they are still needed to make it some we can say that device drivers is one sort of system programs, but they are closely associated with the kernel, not exactly operating system. You would have observed, like whenever you insert a USB drive, or whenever you insert first time the hard disk, it will take some time to install the program, and you will be able to see at the end USB is ready to use. Have you observed that?
Yes, sir.
Why it does that?
Sir, it will install the driver for USB.
Exactly. So that's where the system programs will come. That is not an application, that is not an operating system, but in order to make an interface between your device and operating system, a system program must need it in between. Does it make sense?
Yes, sir. What is that something called? Device something?
Any device, you install any device, first time it will make you to install device driver.
Okay, yeah, device driver.
I will explain that. Okay. In the coming slides, I will explain. So there is, if you see from a mobile operating system often include not only a core kernel but also a middleware. In mobile operating system, it's slightly different. We'll get a middleware. The middleware is also a set of software frameworks that provides additional services to the application developers. For example, a software that supports your database, a software that supports your multimedia, a software that supports your graphics, so on and so forth. Okay, they are all middleware, which is exclusively coming with respect to mobile operating system. Okay. Right. So in summary, when you want to define operating system, the operating system includes always a running kernel, middleware frameworks that uses application development and provide features, and system programs that aid in managing the system while it is running. So these are the main things when we want to define operating system we need to keep in our mind. Okay. So having discussed this, all these things, let us now try to understand what is computer system organization. A typical personal computer system will look like this. So you got processor, you got disk control, you got disks, USB control. USB control is again, you can connect mouse via USB, keyboard via USB, my printer via USB, and USB controller is there. You got a monitor, you got graphics adapter. This graphics adapter will help you to see. You can able to see my laser point is moving. This is also one sort of graphics, right? You will able to see the black font. You can able to see the red font. You can able to see the different points. Different colors, so different graphics you will be able to see on my screen because of this graphics adapter. So whatever it is. So but however, all these resources will share a common memory. You have only one RAM. The size might be different, like 8 GB or 16 GB, but the RAM is common. All these applications has to share the RAM. This is how a computer system organization will look like that we studied. But if you see that a modern general purpose computer system may have one or more CPUs and a number of device controllers connected to a common bus. So here you have a USB controller. You got 3 connections to a USB controller. So these are all different hardware devices connected to memory using a common system bus. Okay, a common system bus will help you to interconnect all these hardware devices or device controller. Device controller, right? A number of device controllers. This is what we are using general purpose computer system nowadays. One or more CPUs and a number of device controller connected to the common bus that provides the access between the components and the shared memory. Now suppose if processor wants to show something, I mean like I want to see something on monitor, I will click mouse. This mouse will communicate to the USB controller. USB controller will load into memory, and from memory it will go to CPU. Then CPU will execute that instruction. That instruction will go to monitor to display. This is right. So the common system bus is way it connects all the components and device drivers. Now the CPU, every time it will look into memory for access, or when an application wants to execute it to go to the CPU, it will load into the memory. Now each device controller is in charge of a specific type of devices. For example, you want to listen an audio, you need to install audio driver. You want to see something graphics visually, you need to install graphics driver. Okay, so they control their respective devices. Depending on the controller, if more than one device may be attached, like for instance USB port can be, suppose I have only one USB port, I can install a USB hub which will make again 3-4 multiple options, right? You understand what is USB hub, right? USB hub will look like
No, sir.
this.
No, sir.
Okay, let me show this. See, USB hub will look like this. Let me show a better picture. So this is a USB hub. It will look like this. So suppose I got one USB. what I'll do, I will connect this USB into my system. Now I got 1, 2, 3, 4 options of USB. This is USB hub. Now I can install, I can insert one more hard drive or one more pen drive, one more printer in that. Still, I'll be able to access that. Okay, so this is USB hub. USB 3.0 is a version. If you see blue color, that is 3.0. If you see black color, that is 2.0. The reason is 3.0 is speed. It's much speeder for data transfer than black color. So that's 3.0. 4 ports hub. You got 4 ports hub. So an USB controller, if I have only one USB controller, if I connect a USB hub, I'll be able to provide to 4 more devices the access. But still, my USB controller will be able to handle that. Okay. So that's what I'm trying to say here. Depending on the controller, more than one device may be attached. Okay, so for instance, one USB port can connect to a USB hub to which several devices can connect. Right. So a device controller maintains some local buffer storage and special purpose registers. The device controller is responsible for moving the data from data between the peripheral device and it controls and local buffer storage. So if this is not making sense, you can hold on for some point when I explain the memory, what is register, what is cache, what is main memory, what are the different memories, you'll be able to understand that. But the way a computer system organization is set up, I guess up to this point, is it making sense? Up to these 4 points?
Yes, sir.
Yes, sir.
Okay. Now, what is this register purpose, special purpose registers, buffer storage? I will explain that. You please bear with me. I'll explain that. So typically, operating system have a device driver for each device controller. Okay. I said that to make you understand simply, when you put an USB drive, you would observe that when it is ready to use, because a device driver is running inside that, but it happens to each and every device. You connect the first time printer, you connect first time your smartphone using a data cable, you connect first time your any application, wireless mouse or wireless keyboard, first time a device driver by default it will install. You can see that how many device drivers are there in your system. I think you see the device manager, you can click start here, go to device manager, you'll be able to see how many device drivers are there for what application you can able to see. So for example, for audio input outputs, these are all the device drivers which are running background. Realtek high definition audio, which I installed, the device driver which is running background. For camera, USB video device is there. For computer, this one, disk drivers, display HD graphics 4600 is running behind. For CD DVD, for human interface, USB input device. For keyboard, HID keyboard device. So these are all programs. Okay, these are all programs. You can update them. You can update your driver. You can disable your device driver. You can uninstall. You can change the driver. Okay, these are all softwares. These are all softwares. We are also called as the device drivers. You can see that we can update the driver if the better version is coming. You can update the driver. In the driver details, you can able to see that this is developed by Microsoft. You can uninstall or update the driver and so on and so forth. You for mouse, for monitor, for network adapters. Network adapters is like Ethernet connection, how the LAN connected. Likewise for other devices, like each and every port. Communication port is what USB ports are, right? Likewise system devices. You see that for each and every hardware inside that universal bus. Okay, for each and every application, there are a lot of device drivers running background. For example, see for the processors, the device drivers are running like Intel Core i7 4000. The CPU. This is a device driver which is running. For printer, I installed HP. I think it should be there. Okay, software devices. So for each and every hardware, you can able to see that there are a lot of device drivers are installed. In the background, the device drivers are running. Okay, so the operating system, when we have a device driver for each and every device, and it controls that how the device will work. So this device driver will understand the device controller and provides the rest of the operating system with a uniform interface to the device. The processor and the device controllers can execute in parallel, competing for the memory cycles. To ensure an orderly access of the shared memory, and a memory controller synchronizes the access to the memory. So on the background, the device driver and operating system will coordinate with each other for the memory access, and how the memory will be accessed in a synchronized way. The operating system will help, but the operating system typically has to do all the job. But again, the device driver is helping even better way to communicate between the hardware and the operating system to make the job even more easier. Okay, is it okay? Is it make sense up to this point? So we will take a break because we are talking since 3 to 4 o'clock, almost 15 minutes. We'll take 10 minutes break. Now it's 3:57. You come back at 4:05. Okay, we'll take 5 to 8 minutes break. Meanwhile, if you have any doubts so far, you please ask. Any questions if you have, please ask.
Hello, sir.
Yes.
Sir, my doubt is what is the relationship between Bootstrap and Kernel program?
Kernel program has to be associated with an operating system.
And Bootstrap
Okay.
is the first program to learn. Oh, yes.
Yes, Bootstrap is the first program that is associated with your computer. When you turn on your power, the first program will be loaded Bootstrap, and Bootstrap, when you install an operating system, your kernel program will be linked to that Bootstrap program. Okay,
got it.
so the Bootstrap is an independent program. It has nothing to do with your operating system. So when there is no operating system, the Bootstrap will load, and it will see that there is no operating system to load. So it will say that we will not able to find an operating system, or CD DVDs are unavailable, something like that. It will show some message when operating system is not there. So when you install an operating system, this operating system kernel is linked with Bootstrap program. So when you turn on power, the Bootstrap program loads by default. Then after loading Bootstrap program, we'll try to look into the program. It is the operating system. When you install, the kernel link will be attached to the Bootstrap. Then Bootstrap will by default load. It will load the operating system. Then the kernel will be loaded. The kernel is associated with an operating system. So when I install Windows 10 operating system, the kernel which will be loaded into my main memory will be related to Windows 10 operating system. Suppose when I'm using Mac OS, then the kernel image will be related to Mac OS. That goes with each and every operating system will work as independently.
Okay, sir. Thank you.
So if anything goes wrong with your operating system, sometimes blue screen error comes, sometimes your operating system will get corrupt, because when you install some virus, the virus will stop making your operating system working mechanism. Then your operating system will corrupt. Then when you try to restart, it will not work properly because your operating system will get corrupted. In that case, still Bootstrap program will load. then it will again stop working because your operating system is corrupted. Then you have to reinstall your operating system.
Sir, what will be the difference between this Bootstrap and BIOS, sir? Because BIOS will also be loaded when we turn on computer.
Bootstrap program is a software, BIOS is a hardware, something like that.
Okay, sir.
You Google and search the difference. What is difference between Bootstrap program and BIOS? BIOS is settings, like so suppose I have I can install operating system via USB drive. I can install operating system via CD drive. I can install operating system using hard disk, and so on and so forth. Right? I can make sure that my BIOS is like way how you are making your bootable program. Now I can make a setting when I want to install an operating system in BIOS settings. You can able to see that. Try to see first the USB port. If nothing is there, then go for CD drive. If there is no CD drives, go for some other device. If none of the devices has no bootable program, then whatever the operating system is there, you execute that. So all these settings will come in BIOS setup.
Okay, sir.
You can able to see that you can start when you start your computer, you press, depends on your computer hardware, the keys will vary, like F8 or F12 or shift alt delete if you are using AMD processor. Depends on your processor or depends on your hardware device how they designed. You can go to the BIOS settings. You can verify that what are the various options are there. It will show that what is your process speed, what are the settings you can do, and you can keep the password. How the BIOS, if suppose a bootable pen drive if I insert, it will ask you before starting an operating system, it will ask you whether to boot it or not. If you say boot, then it may replace your operating system also. All these settings will be there in BIOS setup, but Bootstrap is the program that where you load your operating system.
Okay, sir.
But still, if you are not clear yet, you can Google and search it and try to get an answer. Shall we start?
Yes, sir.
All right. Now let us get back to our discussion. Now we'll try to understand what is interrupts are. Okay. So, consider a typical computer operation. A program is performing an input-output operation. Okay. Consider a typical computer operation where program is performing some input-output operation. So to start an input-output operation, for what happens is first the device driver loads the resistors in the device controller. I told you I'll explain what is what is resistors, right? So resistors is memory that is stored in the motherboard or in the processor itself. Okay, resistors are closely stored inside the processor to execute some instructions. Now, what happens is like when you store a file in your hard disk, that hard disk file is fetched to main memory. That main memory, when it will given to the processor for executing instructions, the processor, although it will take access the set of instructions from main memory, the processor will still have its local way of storing memory using resistors. Okay, so resistors are very faster, very expensive, and it is closely attached with the resistors, with the processor. Okay, so when a processor is trying to execute some instructions, the first immediate memory it will look into is resistors. How it will load into resistors is from cache. Why cache is coming into the picture is because the speed of processor is too high, the speed of RAM is very slow. Compare to bridge a gap between this mismatch of speed, you will introduce a cache memory. Cache is also a memory which will act as a again one more intermediary between your processor and the registers. Okay, so when a processor is executing some instruction, it is fetched from your hard disk to RAM, RAM to cache, cache to registers, and registers, the processor will execute the instructions. Does it make sense?
Yes, sir.
I repeat again.
Please repeat, sir.
I'll
Yes, sir.
repeat. So when a processor is trying to execute an instruction, by default, it should take from the RAM. Okay, RAM is a volatile memory. When the power goes off, all the data goes off. So what you will do by default, you save your file in your hard disk, which is a permanent memory. So in your hard disk, the permanent memory, your files and data is stored. So when you want to execute a file, that file is fetched from your hard disk to RAM, and processor is supposed to take that instruction from RAM. This is the ideal working mechanism, right? Is it okay up to this point?
Yes, sir.
Yes, sir.
Now what happens, the processor is the processor speed is very high and the RAM speed is very low. The processor works in gigahertz per second. Gigahertz means what is gigahertz? 2 to the power of 1 millisecond is 1000 milliseconds is 1 second, right?
Yes.
Yes, sir.
Right. Now you try to do that like that in terms of time frequency. 1 gigahertz is almost, I think, if I'm not wrong, 1 megahertz is 2 to the power of 20, and 1 gigahertz is 2 to the power of 30. So 2 to the power of 30 instructions per second a processor can execute. What is your process speed? Let me see the process speed. See, your process speed says that 3.4 gigahertz. What does this mean by 3.4 gigahertz. Means
Sir,
3 point.
maybe
Hmm.
sir, maybe it is 3.4 giga instructions per second.
Something like that, right? Means 3 into 2 gigahertz means 2 to the power of 30, correct? You can see in terms of memory only. See, 1,000 hertz are 1 kilohertz, right? 1,000 hertz are 1 kilohertz. So likewise, you can see 2 to the power of 10, to the power of 20, to the power of 30, which will be almost 10
Sir, 1
into 10.
billion.
1 billion. So 1 billion instructions per second into 3.4, that is 3 billion instructions per second it will execute per second. Does it make sense? Your processor is that speed. Those many instructions it can execute per second, right?
Yes, sir.
What do you think? What is the speed of RAM? What would be the speed of RAM? Can anybody guess? So I say
In
my
megabytes. In megabytes.
no, that is storage
Okay.
capacity, but speed, what could be the speed? How many instructions can be accessed per second or per minute? It will be like if you want to read one instruction, if you want to take one instruction, it will be taking maybe around milliseconds. Okay, you can compare the speed, the mismatch like milliseconds and 2 to the power of 30 instructions per second. You can see that processor is running very speed, right? But the RAM speed which you are providing the instructions to the processor is very slow. Does it make sense?
Yes, sir.
So when you are reading some instructions from your RAM and your processor is running very slow, what will happen? The process is not used efficiently. The process will sit ideally till the instructions is loaded from RAM to processor, right?
Yes, sir.
The process will execute if it has something on it and it is executing a million instructions per second, say what we computed 3 billion instructions per second. The RAM should be able to match the speed to the processor, but the design of hardware what we are developing, the RAM capacity, like it is not matching the speed of the processor. So to bridge that gap, the cache memory came into the picture. Okay, so the cache memory is faster than the RAM, and it could able to provide the instructions more faster than RAM to the processor. Okay, so the cache memory is good that it will provide a better speed to make the processor to execute more instructions better than the speed of the RAM. To mismatch this processor speed and RAM speed, we introduce a cache memory inside that. Is this okay?
Yes, sir.
Even the processor no need to access cache all the time. To execute few instructions, it will have its own nearby memory locations called registers. Okay, so the processor registers are even faster than cache memory. Okay, so the processor first it will access is registers, where the registers will be loaded the instructions. It is from cache will get instructions from RAM will get from hard disk. But RAM, cache, registers, all these are volatile memory. Okay, only hard disk is permanent memory. They are all volatile, but to mismatch the speed, they have all been introduced. Then you might ask one question: if cache is faster than RAM, why can't we replace the RAM hardware with the same software as cache? RAM hardware as same as the cache hardware is because cache hardware, resistors hardware are very expensive. It's very costly. Okay, so if you want to, you are buying a laptop or a desktop for how much rupees? Your laptop maybe if you are using i5 processor with 4 or 8 GB RAM with 15.6 screen, you'll get around for 50,000, 50 to 60,000. Correct?
Yes, sir.
Yes, sir.
So if you replace RAM with cache memory, then your laptop price will increase to 1 lakh. Will be able to afford.
No, sir.
So when they design a computer hardware, it should be affordable to the common people. At the same time, it should work efficiently, and hence we are using different sorts of hardware, and at the same time we are trying to match the speed, making the processor used efficiently. So when an operating system or a device driver loads, that's what it happens. So here when I say that a device driver, it has a local buffer storage. A device driver controller maintains some local buffer storage and a special purpose registers. This special purpose registers will be specifically used for this application of graphics driver and all these things. So the registers is a memory location where it is closely associated with processor, and cache will come between processor and RAM. And RAM will come in between cache and hard disk. Okay, so that's where a device controller is responsible for moving data between the peripheral devices. It controls to its local buffer storage. So device controller will control the data, how it is moving to the registers and to the local buffer storage, how it will happen because of the device control. So anyway, we'll come back to this. Let us try to understand what is an interrupt. So consider an input-output program. So to start an input-output program, what happens? The device driver will load the appropriate registers in the device controller. So device controller in turn examines the contents of the register to determine what action should take. For example, read a character from the keyboard. Keyboard is an input device. So that input device will be loaded into an program. So let us now, the device controller for the keyboard will examine what are the contents that needs to be, what action should take place. So what will happen? The controller starts, for example, reading a character. When I press something, I'm pressing down arrow and I'm pressing, you are able to see the next bullet point, right? So when I'm pressing something, what happens is the register will read the down arrow and it will start the controller this data from this device to the buffer, means to the memory, to its local buffer. Now once the data transfer is complete, the device controller informs the device driver that the down arrow has instruction is given from the user, and this data has been loaded and it is finished the operation. So this will happen, and the device driver then gives control to the other parts of the operating system, possibly returning the data or a pointer of the data if the operation was read. So whatever the instruction I have given, the operating system will take from that point of view. The device driver will give the control to the operating system. Then the operating system will read what is the action that need to be take place from the data or the pointer if it was a read. For other operations, the device driver returns status information such as write, completed successfully, or device busy. So once this operation read, the operating system will finish the operation what need to be done. Then device driver returns the status. It is ready. What the down arrow, what has been pressed, that action was completed successfully. Or if it is not able to do that, then it will say that device is busy. Okay, either you will get two options. If you want to write something, a character from the keyboard, and all these things will be carried out step by step. So let me let me repeat this point. Suppose you want to perform some an IO operation. Suppose you want to press something to write a keyboard, write something on a keyboard. So IO operation, what it will do, the device driver for the keyboard will load the appropriate registers in the device. When I press something, the device controller examines what is the key that has been pressed, what is the action that we need to take place, that what is the character. Suppose if I press A, that action that A should be printed on the screen. For that, it will try to load from my keyboard to a local buffer to the register. Okay, so the controller, the device controller from the keyboard starts the transfer of data from device to the local buffer. Once the transfer of the data is complete, device controller informs the device driver that is finished its operation. Once device driver finished its operation, it will hand over the rest of the things to the operating system. The device driver then gives control to the other parts of the operating system. So the operating system will return the data or a pointer if the operation was a read. Then for other operations, the device driver again will come back and say that it is ready to read the next before it says that I'm ready to read the next character, it will say that write operation completed successfully. Or if it is busy, it will say device is busy, then we will, even though you are typing the extra keywords, it will not work. Okay, though it says that device is busy. And how does this all this happens is, how the controller inform the device driver that it has finished its operation, how the communication is happening between the device driver and the operating system is because via interrupt. Okay, this is accomplished by interrupt. Does it make sense what I am trying to say? You want me to repeat?
Yes, sir.
Okay. See, suppose this is one interface. Okay, this is an input output operation. Suppose I am writing, suppose interrupt, I am writing something S. Okay, the cursor is blinking. Now I want to something, an operation, say I want to write S. You will be able to see the S. I deleted, then I'm writing S. Okay, when I'm writing an S, what happens on the background is the keyboard device driver. If I'm writing something keyboard, and you will be able to see in the monitor, is because on the background what happens is the device driver for this keyboard will examine what is the action that need to be takes place from the user. When I'm trying to press yes, the device controller for my keyboard will examine what is the content. Okay, when I press something yes, what happens, like, see, when I press something yes, the keyboard from USB controller to memory to processor, it will execute some instruction, right? Okay, now whenever you are trying to do some operation, this device controller for a particular device, it will examine, see, it will examine the contents of the registers. What is the contents of the register? Whatever I pressed, for example, I'm ready to press, the cursor is blinking, I want to read some character from the keyboard. Okay, so now device is ready. When I click something, the cursor is ready now. This process is ready for me to write something on the keyboard. That's why the cursor is blinking. Okay, when I don't write, it will stop. When I write something, it will be ready to read a character from the keyboard. Once I written something, the device controller will start transferring the data. Yes, whatever the letter I have typed, it will transfer the data from the device to its local buffer. Each device driver has its local buffer and registers. That's what we try to understand here. The device controller mechanism maintains some local buffer storage and a set of special registers. So when I press S, the S is stored in keyboard local register. Okay, keyboard local register, local buffer. Local buffer. So once the data is transferred, the device controller informs that the device controller informs the device driver that it finished the operation reading the character S and stored into the local buffer. Okay, now the device driver gives control the other parts of the operating system. So whatever the data I typed, returning the data or a pointer of the data of that particular operation was a read, it will be executed by the operating system from device driver to the operating system. Then once this is done, once the operating system will take over, the device driver will say that write completed successfully. Yes came here. Yes came here means it is successfully. Suppose when I am typing yes and it is not coming here, that means what? When I'm writing yes something on the keyboard, but I'm not able to see on the screen, that means that the device is busy. Device is occupied with something else. That the keyboard is not working or the processor is not working. The process when it is executing or the buffer, something is busy. The device, then it will show that device is busy. All these operations, how a device controller inform the device driver that it is finished operation is through an interrupt. It will give an interrupt. An interrupt is way of communicating some information. It's a signal. Okay.
Yes, sir.
So we have two types of interrupts. One is hardware interrupt and software interrupts. So hardware may trigger an interrupt at any time by sending a signal to the CPU, usually by the way of system bus. Okay. This is when I'm typing something on the keyboard, that is an hardware interrupt. I'm trying to interrupt something by typing something. Okay. So every time the device controller will try to scan or read what I'm trying to do something, and it will send a signal to the CPU. See that user is trying to do something with device. Pay attention. That interrupt will be a signal that will be sent by device controller to the processor via system bus. Okay. Likewise, interrupts are used for many other purposes as well and are key part of how operating systems and hardware interact. Operating systems and how hardware interact with each other is via interrupts. When the CPU is interrupted, it stops what it is doing, immediately transfers the execution to a fixed location. This fixed location contains the starting address where the service routine for that interrupt is located. This interrupt service routine executes. On completion, the CPU resumes the interrupted communication. So before that, the processor is running some application. Whenever I'm trying to see, now the processor is running an application of full screen of this Microsoft PowerPoint. Now I'm going to press escape. When I press escape in my keyboard, I am sending an interrupt signal to the processor to do something. Although this process is running, the processor, after reading the escape, it will take that action first. It will go to that because I pressed escape. That interrupt will be read by the processor. It will stop doing what it does. It will take action of minimizing the screen. Then after the action is done, the processor will go back to run the original process what it is running earlier. Okay, when I'm making it to full screen, again I am sending some interrupt through my left click of my mouse. I clicked something, left click of my mouse. I'm sending some signal to the processor to do something. So inside what it happens is, it's not an operating system is doing that. It's a device controller. From the mouse, device controller is communicating to the operating system. Okay, a device controller or a device driver is communicating to the operating system via interrupt. Is it make sense? So how operating systems and hardware is interrupted. So the device controller informs the device driver using interrupt, and also interrupts are used for many other purpose. Key part is how operating systems and hardware interact with each other. So something like this. So interrupts will happen. Interrupts driven input output cycle is, so the first step CPU is there. Device driver initiates an input output. Suppose keyboard is pressed or a mouse is pressed, some device driver initiates an input output. Let me take the pointer. So what will happen? This device driver will transfer the control to the IO controller. IO controller is initiated. Whatever I am pressed in the input ready, output complete or error generate signal, all these things will be input control, IO controller. So when I'm writing something, or it will show output. Now monitor is also an output, right? Monitor will show the output completely. Keyboard or mouse will read the input ready, or generate some error signal. All these things will be part of input output controller. When some action takes place in input output controller, again the control is transferred to CPU. Now CPU executing the checks for the interrupts between instructions. It will keep on checking whether any interrupts is coming from the input output devices or not. The processor will keep on checking. Once an interrupt coming from an input output controller, the CPU receiving interrupt transfer the controller to the interrupt handler. Now interrupt handler process the data and returns from the input. Then after this interrupt is handled, the CPU resumes processing of the interrupted task. Then it will again go back to the device driver initiate input output. Okay, so this is how the cycle happens. You got input output controller, you got processor. Device driver initiates. The device driver is where a particular device will work or not, that will decide. It will communicate to the input output controller, which will initiate an input output work, either it might be input or output. Then since the interrupt is coming from the input output controller, the CPU is will keep on checking when is there any interrupt, it will keep on checking. Once this interrupt comes, then the CPU will transfer its control to interrupt handler will process the data, returns from the interrupt, and CPU resumes the processing of the interrupt from the interrupted task. Is this clear how the input output controller and CPU works?
Sir, what is the difference between this device driver and IO controller?
Input output controller is for each and every device, there will be a device controller. See, each device controller is in charge of a specific type of device. Okay?
Yes, sir.
Every device will have a device controller. Okay? Depending on the controller, so we simply call that as an input output controller. Instead of device controller, we call that as an input output controller. That's it.
Sir, and how, sir, device controller and device drivers are different? Like, what is the difference between both, sir?
Device driver, device driver for each device controller is different. Like device driver is like a whole program. Decide that how this will device driver is not only for how the device should work or not, but it does beyond that, right? A device driver understands the device controller and provides the rest of the operating system with an uniform interface to the device. You read this sentence. Operating system will have a device driver. For each device driver, there will be a device controller. The device driver will understand the device controller. Also, device driver provides the rest of operating system with an uniform interface to the device. Is it okay?
Yes, sir, yes. And sir, also one more question, sir. Sir, there you mentioned ki each one of these have their local buffer storage or registers. But initially we mentioned कि registers are so costly. So सर हम तो बहुत सारे input device use करते हैं तो मतलब ये तो we have to use many registers. So won't it be
No,
too much
no,
costly?
no. I mean, like every time it will be replaced. When you press yes, every time it will read, the old data will be replaced. The registers, you will not keep on adding the data, right? You will be replacing the data.
Okay, sir.
Sir, like all the instruction of the RAM have to pass through cache memory, or some instruction may go directly from the RAM to the processor.
If it is goes from directly from RAM to processor, then the processor will wait till to read all the instructions should transfer from RAM to processor, right? It will take some time. Ideally, what happens is the instructions will be transferred to cache.
Sir, like this Teams apps consume 700 MB RAM and cache is of 5 or 6 MB, sir, then how it will work?
Where you are saying?
Sir, like this Teams apps are in Task Manager, I see, sir, it is consuming like 600 or 700 MB of RAM, and sir, cache memory, sir, it is very less of 5 or 6 MB, sir. Then how, sir, matlab it will transfer all the instructions?
That's okay. See, your RAM is storing your operating system, your other application programs. It may have sufficient storage space, then it will show your RAM space is more. But cache space, it will show only the program which is currently the processor is executing. So it
Okay,
will show
sir.
only less memory. That's fine. That's totally fine. It don't need to be equal. Shall we go ahead?
Yes, sir.
So
Yes, sir.
we will discuss the storage structure, then we will stop. Okay. For today's class, then we will continue from the next class. So see, when a CPU can load instructions only from memory, so any programs must be first loaded into the memory to run, right? If a processor want to execute any instructions, it will load only from memory, and if it has to run, it has to be loaded into the memory. The general purpose computers run most of their programs using main memory, which is also called RAM, but main memory commonly implemented using a semiconductor technology called dynamic random access memory, DRAM. Okay, so computer use other forms of memory as well. For example, when we run a computer, when you run on computer power on, a simple bootstrap program which is loaded, which then loads the operating system since RAM is volatile. Okay, this is what we are discussing, right? The first program that will load is Bootstrap, which will link to your operating system. Then the operating system will be loaded. But if a CPU has to execute some instruction, it has to come to the RAM. From RAM, it will go to the processor. But I will show you some more example. I will show you subsequently what will happen. So ideally, what we want the programs and data to reside in the main memory permanently. But this arrangement is not possible because main memory is too small to store all the needed programs and data permanently, and main memory is volatile, means it loses its consent when the power is turned off, otherwise it's lost. That's why all the computer systems we are using provide secondary storage, which is an extension of main memory. The main memory requirement for secondary storage is to be able to hold the large quantities of data permanently. So your hard disk stores the data permanently. Your RAM is a primary memory which is limited. So for example, your secondary memory might be 1 TB, but your RAM may be only 4 GB or 8 GB. Still that will work. So your RAM will take the data from your hard disk. It will load whatever the programs that need to be executed, and it will give to the processor, right? So that's how we were trying to understand that. So in larger sense, the storage structure that we discussed, consisting of registers, main memory, secondary storage, is one of the many possible storage system designs. The other possible components include cache memory, We can include Blu-ray, CD-ROM, magnetic tapes, and so on and so forth. The main difference among these various storage systems lies in speed, size, and volatility. Means like it will lose when the power goes off. You see this structure. You see this. The registers is the fastest and closest memory to the processor, and next it will come cache memory. Then it will come main memory. So then main memory we can also call as RAM. This is all these three we can call that as a primary storage. So this is faster. You can see that faster, the access time is very faster, but the storage capacity is very smaller. This will be very small storage capacity. But you come below, it's a non-volatile memory will come, a secondary storage, hard disks will come, optical disks will come, and magnetic. This is tertiary storage. This is secondary storage. Secondary storage where your hard disks will come. Non-volatile memory is a new idea of, you heard about SSD? How many of you heard SSD? SSD hard disk.
Yes, sir.
Yes, sir.
Is there
Yes,
any
sir.
difference?
Yes,
Is there
sir.
any difference between SSD hard disk and HDD hard disk?
No moving parts.
Yes, sir. Sir, SDD
SSD
is
part.
fast.
SSD is fast. Okay, so it has something to do with non-volatile memory. We'll discuss that. We'll discuss what is different between SSD and HDD also. But you try to understand this picture, the storage device hierarchy. Magnetic tapes, you can store it. You can store large amount of data, but to access, it is very slower. The access time, it will take lot of time to read. Optical disc also, it will take a lot of time to read. But you can store huge amount of data. You can store 25 GB in one disk. You can able to store using Blu-ray that we discussed in the previous class. Again, the hard disk where you are permanently stored, and non-volatile memory, they are all secondary storage. You can see that registers, they are very expensive. Their access time is very fast, but the storage capacity is very less. It can't store huge data. If you want to go for a more storage, this will become very expensive. Your computer price will hike to 5 lakhs or 4 lakhs, something like that. Okay, because they are very expensive. Does this make sense?
Yes, sir.
Now somebody asked, this cache memory is it has to go via cache memory or not? It's not must. It's one of the design. Okay, see, you got a processor. Your processor can able to read directly from RAM. The RAM will directly read from hard disk. That is one way of doing that. What is the disadvantage when you do that? You don't have cache in between. You don't have cache memory in between. Your processor is directly accessing from RAM, and RAM is accessing directly from hard disk. This will work fine. So what will happen if that is the case?
Sir, we might not be able to use the full potential of our processor because its speed is high and RAM speed is low, so it won't match.
Exactly. So your system will work very slowly. Okay, your system will work very, it will be not efficient. So to increase the efficiency, we introduce cache in between that will act as intermediate between the processor and the main memory. When I say processor, the processor has that is CPU. CPU has its own local storage that is called registers. Registers will come as a processor inside the processor memory itself. It's a local memory. Registers are kept inside the processors. Is it clear? Does it make sense?
Yes, sir.
Okay, see, the volatile storage will be referred simply as memory. Non-volatile storage retains its contents when even the power is lost. That we called as a non-volatile storage, NVS we call. The vast majority of the time we spend on NVS will be on the secondary storage. There are two types of non-volatile storage. One is mechanical, one is electrical. Mechanical is what HDD, hard disks, if you see, there are two types storage systems: HDD, optical disk, holographic storage, magnetic tape. They are all mechanical way of doing things. SSD, if you talk about SSD, flash memory, FRAM, NRAM, they are all electrical way of storage. So electrical storage will be defined as NVM. Okay. These storage are way faster, but again SSD, they are very expensive also compared to mechanical way of storing. Right now in my system I'm using HDD only, but the laptops that you are purchasing in the market currently, they are introducing this SSD, which is way faster way of working. The hard disk is faster, the access time of SSD is way faster than HDD. Okay. Even 256 MB, 256, yes, 256 MB or 512 MB itself will give you a bit costly of SSD. You can just go through your Amazon or Flipkart, check whether SSD price, if it is there. Without SSD, with SSD, we can try to have a comparison. You can see the price difference range. So mechanical storage is generally large and less expensive per byte than electrical storage. Conversely, electrical storage is typically costly, smaller, and faster than the mechanical storage. So these are the two types of non-volatile memory that we can able to understand. Before starting computer system architecture about single processor, multiprocessor, we will stop here. Today class will stop here. We are discussing so many things. But if you have any doubts so far, you can ask me. Whatever discussed the things, storage structure, you can discuss, you can ask any questions up to this point. Up to storage structure. So computer system architecture we'll discuss next class. We'll stop now.
Hello, sir.
Yes.
Sir, it would be great if you upload this PPTs on Teams, sir. We might need it. Like many of the students were not able to join, or maybe other reasons.
Am I not uploading the slides?
Sir, sir, please tell where, like in MS Teams, you have uploaded like that.
Yes.
Okay, sir.
I'll upload today's class. See, after every class, I'll upload the same class files into your team. I'm uploading now the today's class. You can see the previous class slide in your team. Inside the team class materials, you can able to see the slide or not. Let me know. You'll be able to see the first class, lecture 1.
Yes, sir.
Yes, sir. Yes, sir. It is visible.
So now I'll upload today's class file. You can see that whether you're able to see or not. You'll be able to see the slide, lecture 2, introduction to operating systems.
Yes, sir. It's visual.
Right. So you go through the slides again and you let me know if you have any doubts in today's class. Next Tuesday we will discuss. So operating systems part 2, introduction to operating systems part 2 will discuss on next Tuesday.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.